Hi. So last time we talked a bit about release artifacts, and we started building this Docker image. In particular, what we did was we tagged it with the GitHub repository and the GitHub SHA. And what we wanted to do was get to a place where we could simply start publishing this to the GitHub package repository, because GitHub makes that quite easy. So before we begin, I wanted to I can't remember what we talked about last time necessarily, if we covered this, but I wanted to talk again because I have an article I'm about to publish, hopefully today, about this very subject. What tends to happen with CIs and deployments is there tends to be this linking of release artifacts with deployment artifacts. And I've thought a long time about how to best describe this process with the simplest tools as possible, right? I want to just teach you the simple framework as an example, without really having to use a lot of heavy lifting with other services. And if there's enough demand for me to do that with the other services, like the proper way, I will do just that. But before we begin, a release artifact describes something you've built. But not a lot of people think about producing deployment artifacts. And the reason why you might have a deployment artifact is there might be other versions that a release artifact requires in order to be deployed. There might be secrets or environment variables that need substitution. When you have a deployment artifact, you get this superpower of what I call like scrubbable deployments, right? So every deployment that you make where, let's say you have a bad deploy and you want to roll back, you can just do a forward deploy to any, release artifact or deployment artifact that you've generated. So this means shifting your mentality from I only build artifacts on master to I build artifacts everywhere imaginable. Okay, everywhere that I can build an artifact, I'm going to do it. And every time that I build an artifact, I'm also going to build this other artifact, the deployment artifact, so that I have something going for me, right? So what is important here is this step becomes this step. And then this happens as well, right? So publish deployment artifact. Now this is going to need some changing, and this is definitely going to need some roughing out. And what I'm kind of driving at, maybe a bit by kind of example, a bit by hacking without really explaining, and I'll take a moment to try to explain, is that when you have a deployment artifact, what we're going to do either today or in the next video is try to describe maybe even just a simple shell script that specifies the environment variables or the configuration variables and the actual versions that all play nicely together, so that when we do want to deploy, we will also have a service that we can just ask, and we can say, hello, excuse me, can you please actually roll out this functionality? Okay, so what we are going to do is we're going to get this building and going up to GitHub package repository first. Okay, so this builds it, but we also want to do a few other things. So yeah, cache preview checkout happens, build and publish the Docker image should occur, and then since this is the same step, we'll just say build Docker image, and this one will be publish Docker image. Okay, now this build is fine. We sort of have a name here, which is the GitHub repository and the GitHub SHA with a colon. But the first thing that we have to do before we can publish is this. Right. And let's see if we can log in so the username, what are we going to use? What can we use? The name of your user account and the GitHub token here. So just another dot. And then this token is going to be, what is it again? GitHub token. Authenticating with GitHub token. So this guy is what we want. Get rid of that. Cool. And then now publishing the Docker image is a matter of carrying out this guy. Okay. So we have a tag, and what they actually want us to do is to build it this way. Right, so when we build, let's build it like how they specify. Owner, so just another dot. Excuse me. It's safe enough for us to hardcode these, so the repository is going to be the actions repository. And the image name is just going to be, what is this that we've called this? I think we actually called it actions. And then the version is going to be the GitHub shell. Okay. Now, the last little piece of this equation is the path, which is just going to be the current directory. Okay. And then it says that we should publish this to the same place. So define this guy, yank, paste, there you go. And that should be it. So yeah, github.com, owner repository, image name, version. Cool. You can get rid of that thing. So we're going to build the Docker image, we're going to log into the GitHub package repository, and then we're going to push it. Okay? And every time we run this command on any branch, we should be making publications of release artifacts. Very, very clear. Release artifacts and deployment artifacts is something we want to separate as two distinct things. So GitHub, let's call this release artifacts, artifacts. Push release artifacts to GitHub package repo. And yeah, I'm being a bit silly by capitalizing GitHub appropriately. It doesn't really matter. So the proper way to do this is you'd have some sort of key value store or some persistent key value store. Perhaps you use S3, perhaps you use cloud storage from Google, perhaps you use DigitalOcean Spaces. It doesn't really matter what you use. Even if you had a database like Bigtable or Dynamo, or maybe you had a managed database solution like Postgres or MySQL or whatever. As long as you have some place to sort of save the knowledge of how a deployment should be performed, or knowledge about the deployment. Because, say for example, you have Kubernetes. You might save off the manifests for that. Or say that what we're going to do, right, is very kind of, bare bones. We're going to just use shell scripts, okay? And we're going to record shell scripts and we're going to say, this describes deployment at this date and time. right? How we do deployments exactly then. And that is going to break a little bit if we ever drastically change things. And there will be points in time where particular release artifacts and particular deployment artifacts are going to become unusable. But we're going to kind of build in as much capacity as we can to give us options. Because when a site goes down, when a service goes down, when something bad happens, you want to mitigate as quickly as possible. They call this mean time to resolution. So you want to maximize your mean time to resolution. You want to make it as short as possible. Excuse me, not maximize. You want to optimize your mean time to resolution. Okay? Your mean time to resolution is going to give you the ability to reduce a blast radius of your changes that you produce to master. So if you've got like 3 deployments that have happened prior to you, or 3 deployment options that have happened prior to you, whether or not they've actually been deployed, then now you have the option to go back 1 or 2 or whatever where it actually works. And if something bad happens, you can slowly start to kind of reverse until you find a good functioning place. And this is not the best. You can sort of automate this if you want to. In fact, services like Spinnaker from Netflix actually sort of do statistical analysis after a deploy to figure out, hey, does this actually look all right? And if it doesn't, it will back out to something that does. And by doing that statistical analysis, it can make sure that you don't have to go back a whole bunch to figure out where it was working before. Where this actually falls apart too is shared mutable state, as always, right? Some joke that shared mutable state is the root of all evil as compared to money. There is some truth in that. The circumvention around that is to, not necessarily circumvention, because you'll still get problems, but as long as you're instrumenting everything through code, which is a discussion for another day, that will get you a lot closer. It will bring you to a place that will make you a lot happier, right? Where rolling back, as long as you've made sure that the database changes that you've put in can now be reversed, for example, then that's not such a big deal, right? So like adding a column and then going back to code that didn't use the column, that may not necessarily need a reversal. But if you deleted a column, right, to code that now pretends that the column doesn't exist, and then you reverse back to code that needs to have that column present, that's a problem. And if you don't have code that either reinstates the column or at least gets back into a working place, you'll be in for a bit of pain. And that's where a deployment might become somewhat unusable, right? And you'll get whole islands of deployments that'll become unusable due to certain changes like this. It's not just database stuff. It can be things like infrastructural changes that are coupled tightly to how things work in the system. It could be services that you drop. So maybe you go back to a version of code that's hooked up to a particular third-party service that used to do emails, right? And now you don't use that service, or you're not paying for it anymore, or whatever, then going back to that version could effectively be broken. But fixes around this could be things like being able to turn off those services when you want to, such that at least the site works and the alternative deployment, but you get to pick between the lesser of 2 evils, right? So maybe emails aren't going out in this version, but at least user data isn't being deleted, right? Oops. So let's create this. Let's watch this workflow. Let's see how long we've got for time. Okay. So about 13 minutes in, and let's see how this went. This worked. So we should actually see on our repository a package has been deployed, and this is our version. Okay. It works. So that's awesome. And going back here, build Docker image. We built the Docker image. There was one warning. The process bin tar failed with exit code 2. All right. Well, some caching thing failed from the cache preview step that we're using. So it built this image. It then logged into the GitHub package repository. It then said, okay, I'm going to publish this. So it ran Docker push, and then cache preview came in. And it had no release thing. So it actually, that's something we can change really quickly. The issue is that when we build this image, right, we are checking out stuff, but we don't need to push it up again, okay? So what we want to do, just to fix this quickly, is say don't push, if that's possible. The alternative, you'll see how here this builds. We can, if we want to, actually push the results of this. You'll see here that this build happens, right? Now, this is a bit funky because the build that happens here is happening on Ubuntu, and our Docker file is on Debian, actually. So this is not a huge deal, but it does sort of make a difference for dependencies that we're going to build with. So I'm going to fix this by just saying githubpackage.com, just another dot, actions GitHub SHA, build Docker image. So this guy, we are going to change this to not use the runner. I am just going to use, yeah, let's just say that, okay? Or actually, let's say Docker for the time being, right? That way we're not tying it specifically to a particular Debian release. We're not tying it to Rust or anything like that. We will have to munge it. This might cause problems in the future. In fact, I'm kind of going to make the conscious decision here not to solve this problem right away, which is a really useful skill to have, or to work on at least. And then here what we're going to say is -v. We're going to hook up the, hold on. Let's try that. So what's happening here is we're going to mount the local file system into this Docker container for this build. And by mounting that, let me just remember if I can do that. Docker help, Docker build help. I may not actually be able to do that. Force run quiet, no cache, target string pull, no cache. So, oops. No, actually, we may not be able to do that. So, one alternative is to do caching in here. And this is where you would say something like, before you do this cargo build, you could actually pull the cache that you care about, unpack it, run cargo build release, repack it, repush it up to wherever you want, okay? And that's sort of the pattern that this is doing anyways, but it's just doing it external to this. Now, up here, when we built on the actual workflow. So this was building with Ubuntu, And because of that, the cache that we have here can't be trusted here, which is what I mentioned before. And the reason for that is things can change, like libc versions can change. We don't know which version of Ubuntu is being used and which version of Debian, so there might be incompatibilities effectively. By pulling this down, it will get pulled up into the container, which might be all right if we were using the same thing. But now the way that this cache preview thing works, we can't push that back up. So we're going to just have to temporarily accept that these builds won't be cached. Temporarily disable caching and publish on release artifact. On Docker builds. Yep, so let's push that up. Let's close this, close that. This is our guy. And yeah, so we should be seeing another, where is it? Package coming up soon. This is gonna run, build Docker image. So it's gonna check out. We don't have the cache preview anymore. And that's kind of funny, like, these are all running in tandem. I wonder if... so GitHub workflows depend. Workflow syntax for GitHub Actions depends on... Oh, okay, yeah, so let's do that. That's the other thing. We want to do this into a multi-line step. So we're gonna have this little pipe thingy, right? Build and push, publish, Docker image. Okay, so when we run this, we're gonna say that guy, then we're gonna say this guy, and we're gonna say this guy, and let's just, you know, log in right away. Okay. How much time do we have? Okay, cool. This is all a bit weird, right? It's all happening sequential, in parallel, right? In fact, you'll notice that this GitHub checkout action hasn't even finished, which is a bit sus, right? We want the checkout action to happen first and foremost, and then the other things later, okay? I'm not 100% sure why that's... So let's go steps. Display the path. Run. Yeah. So I think one thing we might get away with is just saying, hey, check out the latest thing. And this may actually change all the stuff locally for the subsequent steps, I think. I'm a bit confused why this GitHub Actions checkout thing. Oh, actually, wait. So when did this finish? This finished in 2 seconds. And it published a bunch of stuff. Now, which branch was this? Switching to 825. So we're going to debug this. 825. Now this SHA should be the one that just got published. Okay, so never mind. Let me put this back. All is fine in the world. Whoops. Okay. Switch to multi-line steps for okay. That actually plays in quite nicely with what we want to do next, because what we want to do next is talk a bit about shell, and I'll do that in another video. But yeah, there you have it. This is actions. This is all the packages we have. The latest version is this. There are also other versions. There's the base layer. And it's tagging these as latest versions. So as an example, okay, if I wanted to log in and pull this down, I could, right? I could take a personal access token or a GitHub token, and I could copy this and I could pull this down. And effectively, when we build some sort of service to do deployments, this is what we're gonna describe. Now, I'm very happy with where we've gotten to. I think from this point in time, what we want to describe is now getting more into what a deployment artifact is and getting more into task running versus building artifacts. So, since we have a couple of minutes left and this is still finishing, deployment artifacts in this tutorial is going to be me finding some really hacky way to store off the scripts that we talked about. And the scripts are effectively going to look something like, you know, Docker pull, what we saw here, and then running it on a server. Okay, that's a really, really bare bones example. And you could instrument this with cron so that you're always running some latest version. You could instrument it where whenever somebody has pushed, you know, a latest tag, then that tag gets replicated across the system. This is really the basis of services like Cloud Run and Elastic Container Service, which ties into Elastic Container Registry. I want to make it really clear that it's not just this version of a thing that describes the deployment. I'm just hammering this idea in as best I can. Whether it's a script or a specification, whether it's like some simple toml, right, or some other configuration format like YAML or something that basically says, you know, our actions thing, version 825 FE blah blah blah, goes along nicely with some other versioned release that I've produced. Maybe we have a, you know, some other sister container that it requires. Because of this correlation between the two things, okay, that's what we're encoding. And maybe in order to run this service as a web application or whatever, we don't need to actually describe this with any other versioned release. Maybe all we need is just some environment variables that need expansion at the time of deployment. Or maybe we sub them in when we save them, parts of them, right? So it's this sort of configuration that I'm driving at that's nice about having that recorded someplace, okay? And when you start recording it someplace, you turn it into a first-class citizen. And when you turn it into a first-class citizen, you have the ability to go between things comfortably. if you are using Kubernetes, you may already be familiar with this. Kubernetes has a functionality called rollbacks. And I'm just sort of encoding this as like a Kubernetes agnostic idea. So rollbacks basically allow you to say, change maximum rollbacks, Kubernetes, please. In total, you might have 60 rollbacks. I don't know what the default is. But you may get, come on. When you do these kubectl applies, right? You can record those actions. And by recording those actions, you set up rollbacks, right? And these rollbacks, here's the history. Oh wait, no, where's the history? There we go. Describe deployments, right? And here you go. Here's the history. So here's revision 1, 2, and 3. And then maybe you want to go to 2. So fantastic. Okay? Forget about SHAs. Commit SHAs. Forget it. It's just a number, right? It's just some unique way to identify a deployment. And you want to have a simple way. And what we're going to do is with scripts. Just as for demonstration purposes, I'm not saying that's ideal. Because there are many different ways to set up a website, a service. There are many different ways to get this thing going. And in fact, I will probably in other videos kind of explore the space a bit with kind of frictionless SaaS offerings. Netlify, Zeit, Heroku, etc. They're all very, useful and delightful. And I'm not endorsing anybody by using these. I just sort of want to show that there are kind of quick and easy ways to do this. But if you have the option of kind of working at a company, outfitting these things, I feel it's my duty to try to make the world a better place by having people not tie deployments to release artifacts, okay? And then you can really start shifting the mental model from let me just kind of build release artifacts every now and again to let me build release artifacts absolutely every single chance I can get. As long as I also build deployment artifacts in addition to that, I will get the ability to choose where I want to deploy without any fuss, right? Because let's say that you have a failure. I've got like 3 minutes left, so I'm just going to go on this last diatribe. Let's say that you have a failure of your service and you want to mitigate it as quickly as possible. What will happen in some organizations is you have to actually click deploy, which will run out this whole big script, or maybe you have to hit a whole CI pipeline to rerun, to rebuild something with a fix or whatever. But quickest mitigation is to go back to a good known state. In Erlang, they have this idea of a supervision tree. And the kind of core philosophy of a supervision tree, which watches over processes and restarts them with particular strategies to get them back into a good known state, is exactly that. Getting things back into a good known state will then give you the peace of mind to breathe and find the actual root causes and fixes so that you're not running around frantically going, oh God, are we affecting things still? Are we breaking an SLA or SLO? Having freedom to think allows you then to say, okay, that didn't quite work. Let me fix this quickly. And then you don't affect users as badly as you would if you just kind of had this like 30-minute CI pipeline that causes a deploy step at the end that's transient. And it also gives you flexibility to say, a philosophical way to model your CI pipelines is everything that you can do locally then can be replicated as, automatically done by the CI. Because again, it's just a generic execution framework, right? So having stuff like caching, having extra stuff like, hitting your deployment service or hitting somebody's deployment service is, totally feasible. And in fact, if you think about it, I was looking before this video, GitHub has this deployments mechanism, right? And I didn't want to use this because I thought it would be, it's too tied into GitHub where there's a very particular payload that they're sending, and I wanted to rip away a lot of the magic in between that. But if you look at this, what they're doing is they have this event handler, they have this sample web server that's going to do their deployments, and this is exactly what I'm talking about, right? And they register this event handler. You can see that they're using ngrok, or however you say it, ngrok, to kind of self-host locally for testing. And the event handler is going to get hit with particular events, okay? And then these particular events are going to get checked. And then we're going to say, hey, a pull request was merged. Now I'm going to perform a deployment. So this is a way to tie it up into specific actions. And then down here, right, you'll see that they have like status updates and stuff. But the core of it is, oh, you've asked me to do this deployment. Now I'm going to create a deployment. And what you can do with this is you could say, imagine, strip away all the GitHub related stuff here, okay? And just pretend that all we have is our service. And just pretend that at the very end of it, we've stashed away somewhere some script, okay? That's marked as latest, okay? Or maybe it has a specific version. And then at the end of maybe master running, we say, hey, please service, deploy the latest thing. Now my recommendation is not to use the git SHAs for publish artifacts, for deployment artifacts. My recommendation is actually to use the build numbers, which should be, mind you, monotonically increasing. That just means that they keep going up, non-overlapping, right? That way, if going back to the example I gave several videos back, if person A deploys and person B deploys, and person A's deploy clobbers person B's deploy because it takes a lot longer, this monotonically increasing number should always be deploying the latest, the highest numbered thing. In the next video, or video thereafter, we'll talk about having a system for deploying these artifacts, or publishing them somewhere, having a way to deploy them with a service, right? So writing something like this effectively, very simply, and having it locally. And we will also, we're not going to get involved in all the, nonsense of like updating statuses and stuff, because that's not the point here, right? You can add that with time. But we're going to have a mechanism to avoid concurrency related issues, right? Clobbering issues, by having a marker that describes what the latest thing is, and always checking for, I want to deploy the highest related thing unless I'm specifically asked to deploy a version, okay? So those three things we'll kind of chip away at, and we're gonna do it with kind of ad hoc tools, and along the way I'll talk about what the better alternatives that you can use are. And that should be it. So hopefully that was kind of helpful, and the next video will be fun as well. See you soon.